In this mini lecture, we're going to talk about another topic in stoichiometry. We're going to talk about percent yield problems. First thing you should know about percent yield is when we talk about percent yield, we're talking about something that's produced. Around this part of the country, our farmers are concerned with their crop yields. They want to know how much corn or how much soybeans each acre is going to produce, how much it's going to yield. And so we're referring to something that's produced. And so when we calculate these percent yields, we have to be calculating it using information about a product, something that's on the right-hand side of our equation. The formula for percent yield is that the percent yield is equal to the actual yield divided by the theoretical yield times 100. The actual yield, that term is just talking about how much was actually produced. And the theoretical yield is when we calculate these problems out on paper, what was supposed to be produced if everything went perfectly according to the theory, according to the recipe. So kind of a real world type example here of a percent yield might be with baking. I like to make cookies. I like to eat cookies. And so a cookie recipe might say it makes 36 cookies. When I'm done, when I go through, I like to taste the dough. When I take the cookies off the cookie sheet, you got a broken cookie. It shows up there on the cooling rack, and you can't leave a broken cookie there. You got to eat the cookie. And so oftentimes when I'm done, maybe I only get 29 cookies when I was supposed to get 36 cookies. Well, in this case, those 36 cookies, that's according to the theory, according to the recipe, that's how many I'm supposed to make. And the 29 cookies, that's what I actually produced. So I could put this into a percent yield formula and calculate and say, well, my actual yield of 29 cookies divided by my theoretical yield, what I was supposed to get, the 36 cookies, times 100 would give me an 81% yield. And now we're going to go ahead and apply these to chemical equations. The chemical equations are recipes for chemical reactions. And first of all, when you get these problems, the first question I'm often asked is, how do I know it's a percent yield problem? This is a very easy answer in this case. If the problem says something about percent yield, if you see the phrase percent yield somewhere in there, it's a percent yield problem. And there are two general types in my class, or two ways I ask the question. The first type, you're given information about the amount of a reactant, and you are asked, you're given the amount of a reactant and the amount of a product, and you're asked to calculate the percent yield. Well, the first thing you should do with this type of problem is figure out of the grams that you're given in the problem, which of those numbers goes along with a reactant and which one goes along with a product. Because the amount that goes along with your product, that is your actual yield. That's what this reaction is actually producing. What you'll then do is take the number of grams of your reactant, and then you'll perform what I call a standard three-step stoichiometry calculation, where you're giving how many grams of that reactant, and you can calculate how many grams of that product, and make sure it's the same product that's mentioned in the problem, how many grams of that product you're supposed to get. This will be your theoretical yield, how much you're supposed to get according to the theory, according to the recipe. If you're not sure how to do what I call the standard three-step stoichiometry calculation, go back and look at my video. Stoichiometry Part 2 talks about how to get from grams of substance A to grams of substance B. Finally, at this point, you will have your actual yield number, you'll have your theoretical yield number, you'll be able to plug those into the percent yield equation and solve for the percent yield. In a minute, I will go through an example of each of the two types of problems. And so if you wait a few minutes, you'll see a worked out example of this. The other type of problem that you're given, you get information about the amount of the reactant, and they'll tell you what the percent yield of the process is. And then you're asked to calculate, well, how much are you actually going to get when you're done? In this type of problem, the first thing you do is identify the number that goes with your reactant, double check, make sure it's a reactant, and then you perform a three-step stoichiometry calculation to find out how many grams of the particular product in question, how many grams of that product you're going to get according to the theory, according to the recipe. Then what you want to do is rearrange your percent yield equation that we had before to solve for the actual yield. And in a few seconds here, I'll step you through how to rearrange the percent yield equation. And then once you've got it rearranged, you can plug in the number for the percent yield that was given in the problem, and you can plug in that theoretical yield that you've calculated. You can plug those into your equation and solve for the actual yield. Now, how do you rearrange the equation? The original form of the equation is the percent yield is equal to actual yield over theoretical yield times 100. Now, we want to work this into a form of this equation where you say the actual yield is equal to, so you've got a formula to calculate that. So we got to get the actual yield by itself. It's over there on the right-hand side with a couple other terms and numbers around it. So the first thing I'd recommend is divide both sides by 100. By doing that, over on the right-hand side, you're going to have 100 divided by 100. The hundreds cancel out. Anything divided by itself is equal to 1, and it goes away from the right-hand side, and we've moved that over to the left-hand side of this equation. Then we've got to move this theoretical yield term so we can get the actual yield by itself. Since the theoretical yield is in the denominator, we will multiply both sides by the theoretical yield. Again, that way on the right-hand side, we'll have canceled out the theoretical yield because anything divided by itself is 1. And we'll have worked this into the format that says the actual yield is equal to the theoretical yield times your percent yield number divided by 100. Now let's go over a couple of examples of these. The first one, if I react 581 grams of aluminum and produce 50.2 grams of hydrogen, what is the percent yield? This is one of those problems where you're given two different numbers of things, but it mentions the percent yield. It's asking for the percent yield. We know it's a percent yield problem. And so the first step that we've got to do here is identify which of these numbers goes along with our reactant, which one goes along with our product. So we look and say, well, aluminum, that's over on the left-hand side, that's our reactant. The hydrogen's on the right-hand side, that's our product. So that number that goes along with our product in this case is telling us what this process actually yielded. We actually got 50.2 grams of hydrogen when we reacted the 581 grams of aluminum. But the next question is, how many grams of hydrogen am I supposed to get? If everything goes perfectly, 100% according to the plan, according to this theory, how many grams of hydrogen am I supposed to get from 581 grams of aluminum? Well, to do that, I'm going to have to do a three-step stoichiometry calculation. So I'm going to set this up to start with the 581 grams of aluminum and calculate the grams of hydrogen. Again, if you're not familiar with how to do this, go look at stoichiometry part 2. I'm not going to work this out in detail. I'm just going to give you the final answer here. It says when you react 581 grams of aluminum, according to the theory, I'm supposed to get 65.1 grams of hydrogen. This is our theoretical yield. We've calculated this. So now, if we go back to our percent yield formula, we now know the actual yield. It was given in the problem. We've calculated our theoretical yield. We can now plug those numbers in. We know our actual yield. We know our theoretical yield. Plug them in, multiply by 100, and we get, in this case, it's a 77.1% yield. We got 77.1% of what we're supposed to get. The other type of problem. 85.5 grams of HCl, hydrochloric acid, are reacted in a process with a 91.4% yield. How many grams of aluminum chloride will be formed? Here we know the percent yield that's been given. We know it's a percent yield problem because it says percent yield. We were given 85.5 grams of hydrochloric acid. Well, we look and say, yep, that's over there on the left-hand side. That's our reactant. It's asking for information about aluminum chloride. That's a product. So what we need to do is we've got to take that 85.5 grams of HCl and figure out, according to the theory, how many grams of aluminum chloride are we supposed to get? So again, we do that three-step problem. We find out, in this case, we're supposed to get 104.2 grams of aluminum chloride, but according to the problem, this process only yields 91.4% of what you're supposed to get. So we go to that formula that says actual yield is equal to the theoretical yield times the percent yield number divided by 100. Our theoretical yield is 104.2 grams of aluminum chloride. Multiply that by the 91.4 divided by 100, and we find out in this case we're only going to get 95.2 grams of aluminum chloride for our final answer.